right, what we're working with today is modeling linear functions, and so these are things that are more word problems and more data that we look at and trying to create linear functions from it. And really we're going to focus on best fit lines. The first thing we're going to do is we're going to kind of learn how to do it by hand when we're given specifics from a graph. We have to remember some things though. There's several ways you can find the slope. You can find the slope by counting and using rise over run. Sometimes that's not going to work because the graph is hard to see, so we might need to use our formula, which is y2 minus y1 over x2 minus x1. So those are the main two ways that you're going to find your slope. The next thing we have is a lot of times we're going to have to write our answer in y equals mx plus b form. And so remember, if I found my slope, then I can put that there. My b is my y-intercept. And sometimes on graphs, you're going to see that. You're going to see where the graph crosses the y-axis. Sometimes you're not going to be able to see that. The next thing we have is our slope formula, our point slope formula. When I have no information that I can see, right, wrong formula, I need to use this formula that we've practiced before. Okay, where you plug in your point that it's given you and you plug in your slope, and then you're able to find y equals mx plus b. There are some things that I need to include because some of these problems it's going to ask you to interpret. When something asks you to interpret, that's asking you to describe it in words. And what's going on in the scenario. So describe in words to explain situation. So what should happen is that I should be able to explain it in words, and someone who doesn't see the graph and doesn't know what I'm talking about should be able to understand, oh, I know what they're talking about. All right, so let's look at this first part. There's not a lot of space here, so we might have to squeeze some things around, but we'll make it work. All right, linear equation. So I have to have it be y equals mx plus b. Well, I have my b. Here it is right here. It crosses the y-axis at 360. So I know I have that, so I need to just find my m. Well, I can count down and go over, but you have to notice that you go different counts. It's not going down one and going over one. They're a little different. Or I can use my slope formula for this one. I think that looks a little easier. So my y2, I'm going to say that this is x1, y1, x2, y2. So 0 minus 360 over 6 minus 0. Well, that's negative 360 over 6, which is a negative 60. So that's the first answer. That is my slope. That is my linear equation. When it says interpret the slope, my slope is negative 60. And so what does that mean? Well, slope is up and down, so it goes down 60, but you have to say what goes down. So you would say distance decreases 60 miles for every hour, because the y is talking about hour, okay? Or the x is talking about hour. So remember that slope is change in x, so you describe change in x change in y for change in x. Because that's what it is, it's y over x. So distance decreases 60 miles for every hour. And because I saw what the unit was. The next thing it asks is it asks to interpret the y-intercept. Well, my y-intercept is here at 360. And what that means is at 0 time, because I haven't gone anywhere, so at the beginning, or you could say when no time has elapsed, there are 360 miles to go. So you could say at the beginning there's 360 miles to go, or when time is 0, there's 360 miles. Okay, so those are a couple options. Let's look at the second one. For the second one, I don't have a y I don't have my b. Up here on the first one, I can see where it crosses. So for the second one, I'm going to have to do some work. So the first thing I need to do is I need to find my m. I'll change colors. Okay, so this is going to be x1, y1, x2, y2. So 95 minus 85 over 20 minus 10. Well, that's 10 over 10. So my m is 1. So now I'm going to use my formula. And I already have my y1. I already said my y1 was 85. And my slope I just found was 1, and my x1 is 10. So I get y minus 85 is equal to x minus 10. I add 85 to each side, so I get y equals x plus 75. And so that is our linear equation. To interpret the slope, remember slope is the change in y over change in x, where our slope is 1. So our y is homework grade. So homework grade, it's positive 1, so it increases 1% because it says percent here for each, down here, completed assignment. Okay, so it's the change in x over change in y. The y-intercept, my y-intercept from our formula, we found out that our y-intercept was 75 right here. So that means when I've done 0, when 0 homework assignments are done, you have a 75%. So when you start off, your grade starts at a 75%. That's what that says. Okay, so these can be tricky. You definitely have to look at the situation because you need different things. Remember, you have to have a slope. You have to have a y-intercept. Sometimes you can see both of them. Sometimes you have to use formulas for them. Okay. All right, the next type of thing that we're going to be doing is talking about scatter plots. A scatter plot is a graph of ordered pairs, or it's a graph of data. Ordered pairs. Oops. Or data that show a relationship. So here's an example where this is weight versus height. There's something called a correlation coefficient that our calculator will give us, and sometimes I'll give you, and you just have to talk about it. R has to be close to -1 or 1. The closer the data points are to the line. So in order to get R, you have to turn your diagnostics on, and I'll show you that in class on how to do that. But this is what happens. When I have all these points random, like I have in the middle, the correlation is 0. When I have points that are kind of farther apart, they're not as strong. But when I have points really straight in a line, like I do on these left and right, those are perfect. It's very rare that things are going to be perfect. They're usually going to be decimals. Now, what I want you to notice right here is that when my slope is positive, my correlation is also positive. And when my slope here is negative, my correlation is also negative. So that's an important thing to remember. All right, so when we do best fit lines, a best fit line is a line that fits as close to as many points as possible. I'll show you by hand how I might draw one, but eventually what will happen is we'll use a calculator to calculate the steps and find the equation that way. And what it does is it's going to give us a y equals mx plus b formula. They usually are going to have bad decimals and things that we have to round, but that's okay. So a best fit line is something that goes as close to as many of the points as possible. Let me see if I can do this. I would say that one, no, that's probably not good. Let me try another one. I'll change colors. Let's see if I can make one a little better. That one's a little better. It's as close to many of the lines as possible, so that is the better, best fit line. And again, your calculator will do it manually, or your calculator does it so that you don't have to do it manually. So I think the part that's going to be confusing from this section is knowing what to do when you're given graphs. And really, you just remember, you have to find the slope, you have to find the y-intercept, and then you have to be able to interpret those.